Alright, so today we're going to be talking about 3D printing. So what we're going to do is go over the basics on how the machine works. We're going to touch a little bit on the programming, how that works, and we're also going to be going over some examples of what it can be used for. So starting out here, you'll see there's three main components to the printer. There's the power box here. This is the computer. It's like the brains of the operation. There's the printer itself, and then you'll see the spool of filament. So the filament is the material that the printer uses to print. There's all different kinds of filaments that range in strength and flexibility. This one that I'm using here is called PLA. That stands for polylactic acid. It's a really simple one to use. It's really easy for getting started. It's not the strongest one, but it's reasonably strong and it has a very wide range of uses. Looking at the printer, there's three main components. There's the bed, there's the nozzle or the hot end, and then there's stepper motors. So a stepper motor is a small brushless DC motor that breaks a full rotation into equal steps. So pretty much what that means is you can make that move exactly how much you want it to move, at the exact speed that you want it to move, exactly when you want it to move. So there's four stepper motors on the printer. There's one for each axis. So one of them moves the print bed back and forth. One of them moves the nozzle side to side. There's one down here that lifts and lowers the hot end. Don't mind that. And then there's one on the extruder. So the extruder is pretty much, there's two gears that sandwich the filament, and when they rotate, it pushes the filament through the extruder, through this extrusion tube, and into the hot end. At that point, it's called a hot end for a reason. When it's going, that hot end is at 200 degrees Celsius for the PLA. You can adjust it. Different filaments use different temperatures. For the PLA, we use 200 degrees Celsius. So as soon as that plastic hits the nozzle, it melts, and then it can lay down a bead on the print bed. So it pretty much works just like a frosting bag when you're frosting a cake and you squeeze it and you lay down a bead of frosting on the cake. It's the same thing with this. It just lays down a bead of plastic on the print bed. So next thing we'll talk about is a little bit of programming. So this is a program that I use. It's called Fusion 360. This is what I use to design what's called an STL file. An STL file is just another kind of file like a PDF, but it's for a 3D object. With this, you can design your own, like I have here. You can also just download STL files off the internet. There's millions of free designs, some that you can even pay for. And then here we have what's called a slicer. So what you do, you take your STL file, you import it into a slicer. What this does is it takes the object, it breaks it down into the individual layers, and it determines the path that the printer will take to print that. Now the slicer turns that STL file into what's called a G-code. So a G-code is actually a text file. So if you're smarter than me, you would actually be able to, in theory, just type out a G-code and you could print with it. Of course, that's not efficient, but it is possible. So from there, you take that G-code, you put it into the printer, and then it'll print whatever that object is. Next, we'll talk about bed adhesion. So that's getting the filament to stick to the bed. You can see here that I have painter's tape on the bed. I do that because the filament sticks very well to that. And then also, you can remove it, like 8 out of 10 times you can remove it after the print is finished without actually tearing up the paint, so you can reuse it. When I first started out, I was actually just using glue stick. I didn't have the tape. I would just put a layer of glue on there, and then that worked well as well. But it was just a lot more cleanup in between each print. You'd have to wash it and apply a new layer. So with this, it's a lot less maintenance with that. Another big thing with bed adhesion is bed leveling. So what that means is getting the exact correct distance between the print bed and the nozzle. The reason that it's so difficult is because we're talking a fraction of a millimeter. It has to be the perfect distance away, or else it won't stick, or the print will jam, and then you'll get a clog. You'll see these knobs here in the front. There's one in each corner. I actually printed these knobs to make it a little bit easier to fine tune. So there's one in each corner, and they raise and lower the bed, so that's how you do the leveling. But then once you get it leveled, it's pretty much set and you're good to go. Now I'll just talk about a couple examples of what you can do. I have made some useful things I've printed a lot of hangers that I use out in the garage, things like that. Here I just kind of have some trinkety items just to show what you can do with it. This is kind of a cool print because it has moving parts. So that came off the bed all in one piece with moving parts. It's the same with this. This is a little octopus. This was not assembled. It was printed all in one piece. Came off the bed just like that. This is an example of something a little more useful. This is something that I designed. It's just a fan blade. I had one that was broken in half, so I just made a perfect replica. And then lastly, I'm going to show you this. This is a grip for my shotgun. The reason I'm showing you this is because the print actually failed halfway through. So this shows you what the inside looks like. This has 20% infill. It could be hollow, it could be solid. With this, I obviously wanted it to be strong, so I made the walls really thick. Then I just went with 20% infill in the middle. So those are just some ideas of what you can do. So again, here we've covered how the machine works, how the programming works, and what you can do with it. If you have an interest in 3D printing and you're a little bit tech savvy, I highly recommend getting one. They've come way down in price, and it's just really cool that you can come up with an idea in your head, and then a few hours later you can actually have one in your hand.